Hi everyone, and welcome back to the channel. Today we're going to start covering the much requested Controlnet. Now, this is going to be split into several videos to make it easier for everyone to find what they want. Today we're going to cover what is Controlnet, why you'd want to use it, and how to use it in ComfyUI. The next video will cover the same but in Automatic 1111, and eventually we'll do a deeper dive into how Controlnet actually works in conditioning Stable Diffusion models to get the inputs that we desire. I'm also happy to do additional videos on specific Controlnet models. Please let me know if there's any you'd like me to dive deeper into in the comment section below. But before we start, for those of you who've heard about Controlnet but don't have any idea as to what it actually does, it is a series of models that can provide additional inputs to Stable Diffusion to provide more control over what the final image looks like. And here on the screen, I've just got a simple example of me taking a pose and creating a new image with that pose. Now, depending on the model that you use, you can provide different inputs such as poses, as I've done here, sketches, line art, or even depth maps. And these will condition your Stable Diffusion model to provide an output that incorporates that input into the output. To simplify, what that means is that you can now create consistent elements in your Stable Diffusion images, whether that's having your images have the same pose, the same room layout, or even simply maintaining certain characteristics of a character or creature in the image. It can be very powerful, and today we're going to dive deeper into how to make the most use out of it. Now, before continuing, I just wanted to remind you guys to please like and subscribe. It really helps the channel out as we work our way towards 1,000 subs. I also just wanted to mention my Patreon. I currently put out a video every 7 to 14 days, depending on how busy I am. I have a ton more videos and ideas I'd like to dive into, and I'd really like to bring on board an editor to help, as this is my biggest bottleneck. The funds also help cover the cost of making the video on RunPod, and if you really want to support the channel, please check it out. Now, diving into Controlnet, we've already discussed how, depending on the Controlnet model you use, you can influence your Stable Diffusion output differently. So let's go through each of the models and understand what they do and what their inputs are. So the first model we're going to look at is the Controlnet canny model. And as it says here, the canny model is what the canny model looks at is a monochrome image with white edges on a black background. And we can see here in enlarge what the canny image looks like. And we can see here the background is black and the outline of the subject is drawn out here in these lines with details drawn in to represent the feathering pattern. And when we plug that into Controlnet along with our text prompt, this is the output that we get. And we can see here that the output looks almost exactly like the input with color and detail added in. The next model is what's known as a depth model. Now, Controlnet has now different variations of this. This is the regular depth model. There's also one called the Zoe depth, which is a more detailed version of this model. It gives you more control, including allowing you to represent different depths in different colors so that you can specify even what the distance is from the camera in meters. But for the purposes of this video, we just need to understand how a basic depth model works. And we can see here, again, the background is black, but there's different areas which are shaded in gray, and you've got the subject here outlined in white and different shades of gray, which tells us that this is the subject of the image, the shape of the subject, and where the different elements are. We can see here, for example, the neck area is a little bit darker, which represents it being slightly further away from the camera. And we can see here, this is what the output looks like. The overall shape is the same. The camera understands that the background is further away, which is why it's blurred out. And based on the text prompt, which unfortunately we don't have, it's able to understand that this is a person and where the different facial features go. The next model is the head model. And this one, like the canny, works by detecting soft edges on a black background. Now, interestingly, let's pull it up. Now, interestingly, this image input has a lot less detail than the canny one and almost looks more like a sketch. We can see here the outline of the subject is displayed. There are some details that are drawn on the inside of the bird. They're kind of almost shaded in, I would say. It's not quite a sketch, but it is like a soft representation of the bird. And the output is this one. And again, the performance is very similar to the canny one. There's probably less detail input here by the person and more by the model, because we didn't come in here and draw these details in like we did on the canny model. And just for comparison, this is what the canny output looks like. And again, we don't have the text prompts with us to see what was changed in terms of the text prompt, whether the AI here decided to put more color or vibrance, or whether it was determined by the user. Next, we have again another line-based canny. This one similar, now we have another line-based input. And like the canny, these are harsh lines on a black background. And this almost looks like it's something that's drawn in paint. And this could probably be a very useful model for interior designers, where you could sketch out the details of a room just using straight edges, straight lines, and then you get an output like this based on the prompt. It would be interesting to see how this compares with a canny. If you want me to do some comparisons in terms of creating environments with the canny model and with the head model, please let me know in the comment section below. Essentially, they're both edge-based models, taking edges and outlines and turning an image out of that. I'm just going to skip over this one because I honestly haven't seen this model used much in my research. Now, this is the OpenPose model, and this is probably the one that I've seen used the most commonly. And what the OpenPose model does is it takes an input, which is this image of a stick figure, and you'll notice that each of the elements of the stick figure are a different color. And so the model understands each color to represent a different body part. Now, there's different ways that you can create this pose. I believe that Blender has the capacity to output OpenPose models. You can draw them on Photoshop. And essentially, when the model takes this in, it understands the different body parts and create an output that represents that. So we can see here, this is not the best output, but all of the body parts are in the right place relative to the model. We can see here that the arm comes down, the shoulders are here across, the shoulders are across. The other arm comes around here, which, is a little deformed. That could do with a little bit of tweaking, but we can see here the shoulder, the arm, the elbow, and the hand comes up, and then these are where the facial components are. Now, interestingly, I'm just going to dive into the OpenPose page, and we can see here another example of one of Djokovic. Djokovic? I think that is Djokovic. And a more detailed version of the model, and we can see here that you can actually even define details in the hands in the OpenPose, and even the face is drawn out in more detail, allowing you to specify even facial expressions. And we can see here how in this, this is not the OpenPose output, this is the input. So they've taken this image, created a OpenPose pose out of it, and then given a output from the model. And you can see that, again, it's not the best output, but all of the pieces are in the right place. Coming back, we've now got here the Scribble model. And this one is really useful, again, for people who aren't artists. And this is actually a really well-drawn scribble, but I've seen examples of situations where people have just drawn out basic shapes, told the prompt what they want, and then the model is able to figure out what the scribbles mean, what the prompt is trying to get the scribbles to mean, and then give you an output. And again, we can see here the general shape of the person follows what we've outlined in the scribble. The final model is the Seg1, and this one is also really interesting. Similar to the depth map, it's got different objects in it, but instead of representing depth, each color represents a different object or type of object. And we can see here how, for example, let's look at the final image. We've got this bookshelf here. The orange parts represent things on the shelf. Here we've got two sections of gray, which represent the wall. Blue is the chair, green is the table, purple is the sofa, white is the window. And we can see all of those elements represented here in the final image. Now, before continuing on, it is important to note that the Controlnet models come in different formats and for different Stable Diffusion models. So the original creator, Sdxl, has released a series of Controlnet models, but all of their models are for Stable Diffusion 1.5. It's also important to note that the Controlnet models issued by Sdxl also come with Stable Diffusion 1.5 already bundled into the model, meaning that you won't be able to use it with your own checkpoint. Instead, what you want to do is you want to actually look for the models that contain only the Controlnet component, which are much smaller in size, so it will be easier on your hard disk space, and you can then pair it up with whatever Stable Diffusion checkpoint you want. On top of that, there are two different versions now of the Controlnet models, the ones trained on 1.5 and the ones trained on Sdxl. Not all of the Controlnet models have been shifted over to Sdxl yet, and they have not been created by the original creator. Instead, they've been created by different organizations. I'm sure that we will get more Controlnet models from Sdxl at some point, but for now, we are using models for Sdxl created by third parties. In my case, I'm using the models created by diffusers for Canny, Depth, Zoe, by Tbod for OpenPose, and then Tencent Arc also has another Canny model. So now that we've gone through the models and we understand what each of them do, the next question that comes up is, how do we get the input images? For some of them, like for example, the canny one, this seems like something overly complex and something that may be difficult for people to create, especially if you're not an artist. And even if you are an artist, the time and effort it would take to draw this out and put in all of those details, you may as well just continue drawing it out and creating the image yourself. So how do we get an input image from this? Well, one of the most common ways to use Controlnet, and regardless of the input that you're having, is a lot of times we use a reference image. So let's, in this case, find the reference image for us to use. We're going to do a dog. So let's grab here just a dog. Here we go. Perfect. This is a great one. And what you do is you feed that image through something called a preprocessor. And what the preprocessor does is it takes the source image and then it will spit out an output based on the parameters that you give it. Now, I am using some custom nodes, and here is the one that I used to get it. I've included a link to the images in the description below, so if you want to download them and follow along, please go ahead. They're also available on the Patreon. So we're going to grab here the canny. So we've actually got two. I believe this one comes with ComfyUI. And then there's one which we downloaded from the custom nodes that we brought in earlier. So we're actually going to try them both and see how they perform. Now, because we're using Sdxl, just remember to set your resolution to 1024. And we're going to grab our doggy image. Now, we're going to go ahead and feed it into both cannies. And before we do anything, we're just going to feed them into a preview just to see what we get. So we can see here both canny nodes gave us an image output that we could use later. And we can see here that you've got all of those details drawn in, probably enough to make a face. So we're going to use the one from the custom node because it's just given us a nice starting point. And we're going to try and turn this dog into a bear, because I can definitely see some elements here that look like they could work for a bear. So we feed this now. So now to use this Controlnet input, we need to add in a couple of important nodes, which are here. One is the load Controlnet model. So we can find it here, we type in Controlnet. We see here Controlnet loader, and that allows us to use the model that is going to interpret the input. In this case, we had OpenPose, and we want to use a canny one, which I do not have here. So if we head back over to diffusers, we know that they have a Controlnet canny model. So let's open it up, head on over to files, and they have here safe tensors version. So we're just going to grab the regular one and copy the link address. Now, if you've got this installed on your computer, or whether you're using RunPod like me, you want to head into your models folder, and where it says Controlnet, this is where we want to drop the model. So in my case, I'm just going to open up the terminal, make sure I'm in the right folder, and grab a wget with the correct model. Okay, and now that we've got the model downloaded, we can go ahead and refresh. So it did download it with the same name as what I had earlier, so we're just going to rename that to canny to canny.savetensors and refresh. And we've got it here. So let's feed the image in and let's change our positive prompt to bear looking at camera smiling. And let's cue it up. And while not perfect, you can see here, well, let's try and enlarge this, that the basic elements of the canny are there, right? We can see the positioning of the nose, the positioning of the mouth, the location of the eyes, all of those details are there. And interestingly, because we've only got the snout, we have enough blank space or negative space for the model to fill in the rest of the shape of the bear. So now let's look at OpenPose, since this is the other one that is most commonly used. Now here's one that I had prepared earlier, where we've got this model, again, I got this off the internet, where, you know, she's standing here against the background. We want to take this pose and make something similar. Let's say we like it and we want to use it for something else. So like before, we've got the preprocessor here. In this case, it's OpenPose pose recognition. I almost forgot to mention, if you do want to use this custom node, make sure that you have the node manager installed. Then go in and search for the author who created it, Fanovel116, and then it's the ComfyUI Controlnet auxiliary preprocessors. If you try and look for it with the node name, it may not show up. This is what happened to me. We've loaded the OpenPose XL2 Safe Tensors model. We've applied a strength here. So I didn't get into this earlier. So earlier we loaded the Controlnet model. I completely forgot to mention we also need to apply the Controlnet. So we've got here a node that does that specifically. And what's happening is we take the text input and plug that into the apply Controlnet node. We then take the image generated by the Controlnet, which before was the canny, now it's going to be the OpenPose. We feed that in. We take the Controlnet model, and then it combines all of that information to give you a conditioning, which you then feed into the positive. We are using this to feed the model and tell it what we want. You could also do this in reverse, where we could feed in a Controlnet model with a canny and a prompt as a negative input, telling the model what we don't want. So, for example, we have the same image, and there's elements from the image that keep coming into the final image that we want to remove. We could create a input model that simplifies it and simply looks at the elements we don't want. Let's say, for example, we've got a background in the moon, right? And through the edge detection, that moon keeps coming up and we just want to get rid of it. We could recreate that same image, rub everything out except for the moon, turn that moon into a negative input, and in theory that would remove it. If that's something you'd like to see me experiment with and do a separate video on, please let me know and we can do an entire video experimenting with negative Controlnet inputs. So once again here with the apply Controlnet, we can also set a strength, meaning how much impact do we want the image Controlnet to have on the final output. And we're going to queue up the prompt here. And we can see here more or less everything is in the right place. Now, I am only using at this point the Sdxl base model. And so the image quality is not the best, but we more or less have here the elements that we want. You can see here the arm comes down in the right way. The arm is here correctly. If we look at the prompt, we can see here blonde woman holding sunglasses in her hand, smiling at the camera. I mean, it's all technically there, but we do have some issues with deformation. So we're just going to clean this up with the refiner model and see if we can get it cleaner. Again, I do have a video plan coming up on doing hand and face replacement to improve the output of that as well. Okay, and we're back. So what we've done is, as we've done in previous videos, we have extracted the descriptions from the clip into text boxes. We have created the refiner section here where we've added in those same clip text encoders, connected them up. We replaced the K-sampler for the advanced one, set up the steps. Again, if you want to know what is going on here and the details of how the K-sampler works and why we have made these changes, please check out my previous videos. And we've kept these steps here at 20 with return leftover noise in the K-sampler, ending at step 17. And I personally usually like to re-add a little extra noise in the refiner one, meaning that we need to add in a couple of extra steps. Start at step 17. We've got the refiner model loaded in. And let's see what the polished version looks like. Right, we're not feeding in the latent image. And the model. So let's try that again. So we can see here the finished image coming out of the refiner. There's definitely more work to be done here. The hands I'm still not happy with, but it does look a little more polished than it does before. I think the seed changed, which is why the character has a different outfit. It still kind of has this airbrush look to it. So I'll be posting this image on the description section below. If you want me to continue working on it and refining it, I will be posting additional refinements for this in the Patreon. And I think I'm going to end the video here because we could just keep going on and on about how to use Controlnet. I hope this gives you guys a basic understanding of how Controlnet works, how to set it up in Comfy. If there's anything that you want me to dive deeper into on Controlnet, please let me know.